Many collisions, it seems, over the course of the history of this particular group. So it's very complex.
The Hubble Space Telescope images of Stephan's quintet are a highlight reel of galactic body slams and pile drives. But in this case, Hubble sees creative destruction. Whole dwarf galaxies forming in the wake of the collisions. But once formed, the future for these infant galaxies is anything but certain.
What will happen? Will they, in fact, go off and go into the group in general and float around out there and live happy and productive lives? Or will the giant galaxy there, the parent, eat the child?
The answer could help settle an old debate in astronomy, whether today's galaxies formed when smaller star groups piled up together, or if they're the surviving offspring of earlier galaxies. The Orion Nebula, one of the most beautiful, most photographed regions of the sky, may also be home to dozens of planet-forming stars. Over the past few years, astronomers using the Hubble Space Telescope have surveyed Orion and the stars and gas clouds within it, finding young stars so early in their formation that they're still surrounded by disks of leftover debris. Now, they think they have evidence that the first steps of planet birth have started. But these early results seem to be a mixed bag.
On the one hand, we have these situations where disks are observed and are capable of forming planets, yet they don't have much time to make the gas giant planets. Yet at the same time, these same disks, we see that the process of beginning to form solid bodies is already well underway. And so it's sort of a good news, bad news situation. The good news is that, wow, here are disks which can form planets and we can see the process already beginning. The bad news is you better do it fast because otherwise you're not going to have enough time to gather the gas.
That gas is needed to form gas giant planets such as Saturn and Jupiter. In Orion, Hubble sees for the first time the beginning stages of dust clumping into the pebbles that could eventually form rocky planets like Earth. But Orion's powerful central stars are burning away the gas around the planet-forming disks, maybe halting the formation of gas giant planets before it can begin. The eventual outcome of the planet survival drama in Orion could have far-reaching implications for the abundance of planets and life. Donuts, rings, even an eye. What are these shapes? They are the beautifully diverse forms of planetary nebulae. About 1,000 planetary nebulae have been cataloged, each unique like snowflakes. Early observers viewed the night sky and saw these fuzzy disk shapes. They thought these fuzzy shapes were planets, so they called them planetary nebulae. These beautiful nebulae, however, have nothing to do with planets.
A planetary nebula is the gaseous nebula created by the death of a sun-like star. And when a sun-like star dies, it ejects its outer envelope, and the core of the star, which is really hot, makes the nebula glow. And this core will eventually become a white dwarf.
This glowing hot central core is a huge shell of expanding gas. As astronomers studied planetary nebulae, it was found that these shapes were more complex than previously thought. Were the differences due to how the gas shell evolved during expansion, the angle from which they are viewed, or do each form in a different way? Intrigued with these complex differences, a team of astronomers used the Hubble Space Telescope to explore the Helix Nebula. The helix makes a wonderful candidate to study because it's so close to Earth that astronomers can study its intricate details. Its apparent viewing size covers a patch of sky almost the size of a full moon. Ground-based observations had shown a spoke-like pattern in the helix. The Hubble showed finger-like shapes along the inner edge. Each has a bright head and a long tail. Astronomers named them cometary knots. The team was so fascinated with the helix and its many intricate shapes that they pulled together data from many observations made by a variety of telescopes to get a clearer picture.
The Helix Nebula was interesting to us because it wasn't what we expected. What we expected was something much like my glasses here, where we'd have a rim and then we'd have a disc of material like the glass lens I have. And then what was interesting to us was that the glass would be tipped with respect to the rim. So in the Helix Nebula, the disk is tipped with respect to this ring.
Astronomers constructed a 3D model of the helix by combining the high resolution of the Hubble, ground-based images from Cerro Tololo Inter-American Observatory, and measurements from other telescopes that show the speed and direction in which the material is moving. In this model, we see two disks, an inner and outer, almost perpendicular to each other. Along the inner and outer disks are the cometary knots, or fingers. This enhanced image only leads to more riddles in the puzzle of how sun-like stars transform into beautiful sculptures in the sky, known as planetary nebulae.
And find enough galaxies that we can actually chart the trends of evolution over time.
The survey captured tens of thousands of galaxies at all stages of development, making it the richest core sample of the universe ever taken. As we piece together the sizes and distances of all these galaxies, we're building a greater understanding of the formation and development of galaxies like our own. The Good Survey is like a time machine, revealing more than 10 billion years of cosmic history. From the nearby galactic neighborhood to the distant edges of space and time, NASA's Hubble Space Telescope, America's premier orbiting observatory, is leading humanity into a deeper understanding of the universe.